So permutation and combination. This guy, you can term this guy to be arrangement. Why combination? It can be choice. It can be selection. Can say they pick something from something, picking, or they are forming a group from a group. So anything related to this we still have more examples that we can liken combination with. But permutation most especially is based on arrangement. So if I say in how many ways can we arrange the letter A, B, C such that two letters must, like, can we arrange two letters? I mean two letters from the letter A, B, C. Like if you want to arrange them two rather, if you want to arrange this letter two, A, B, we can have A, B, we can have B, C, and we can have A, C. But the fact that we are talking of arrangement, you can see have B, A, you can see have C, B, and you can see have C, A. So this is not same thing as this in terms of permutation. But in terms of, so for permutation now we have 6 ways. But in combination we only have 3 ways, because combination, the same choice as A, B, same thing as B, A. If I choose a biro and a pen, the same thing as choosing a pen and a biro. Whatever. A biro and a pencil, same thing as choosing a pencil first before a biro. But the arrangement differ. So for permutation, you can have 6 ways of the arranging them, of the arrangement. But for combination, you only still have 3 choices rather. These two are just one choice, another choice, then another choice. So we have 3 choices. So for permutation, we can call this guy, because there are 3 letters available and you want to arrange them 2. So that's going to give you 3, the whole letter permutation 2 in 2 arrangements. But for combination, it's going to be what? 3. You are choosing 2 from 3. 3, like this, 2 out of 3. 3 combination 2. So for permutation, the formula, whenever you want to permutate a number from a group of number, or you want to permutate something from something, the formula says n permutation r, are we together, equals to n factorial over what? N minus r factorial. That's permutation. But for combination, n combination r will give you what? N factorial over what? N minus r factorial, r factorial. Yeah, multiply by r factorial. So that's the combination. Are we together? So that's that for that. So for this 3 permutation too, because we have 3 letters and want to arrange them 2, that's why it has to be 3 permutation 2. So it's going to give us 3 factorial over 3 minus 2 factorial. That's what? 3 factorial over 1 factorial. 1 factorial is 1. 3 factorial is 3 times 2 times 1 over 1. That's 6. So 1, 2, 3, 4, 5, 6. That's it. For combination, 3 combination 2, because we want to choose two letters from what? From 3 letters. So it's going to give us 3 factorial over what? 3 minus 2 factorial 2 factorial. So here we have what? 3 factorial over what? 1 factorial 2 factorial. 3 factorial is same as 3 times 2 factorial. You can still bring it down to 1. 2 factorial is 2 times 1. Exactly. So here we have 1, 2 factorial at the denominator. So this cancel this. So we have 3 over 1, which is what? 3. All together. So that's that about that. Let's keep that aside now. Let's move to now. Write in factorial form this. That number The factorial form is, since it's 5 times 4 times 3 times 2 times 1, the factorial form is what? 5 factorial. Now number B, this B, 7 times 6 times 5. It is not 7 factorial, but it's going to give what? 7 factorial over 4 factorial. How did I know? This 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. But they stop at 5. So how can I reduce this to 5? This is the question. How can I change this? This is it. 7 times 6 times 5. So since 7 factorial is this. So to now get this back, the factorial form of this question will now give you over 4 factorial. You know, this everything from here to here is 4 factorial. 4 times 3 times 2 times 1. So this cancel this. So now I have this left. So 7 times 6 times 5 is same now 7 factorial over 4 factorial. 7 factorial over 4 factorial. So that this cancel this. You now have this left. So that's that one. Now the last one. It says n into n minus 1, n minus 2. Now, listen. n factorial equals to, no, assuming we know what n is. This is the idea. Assuming n is 7. You know, 7 factorial. 7 factorial is 7 times 6. And you can write that 6 as 7 minus 1 times 5 times 4 times 3 times 2 times 1. Is that clear? So this is 7 times 6 times 5 times, so that's 7 factorial. Or you can stop at 7 times 6 times 5. If you don't want to continue, times 4 factorial. You can end it with factorial. If you don't want to continue to this, putting factorial there means is that there is still extension left, but you don't want to stress yourself. If you want to write it to the list, you still continue 7, because 7 times 3, 7 minus 3 factorial is something as 7 minus 3 times 7 minus 4 times 7 minus 5 times 7 minus 6. So n factorial, because we don't know n factorial can be written as n into n minus 1 factorial. It is also something as n into n minus 1, n minus 2 factorial. If you want to add the third one, it can be n into n minus 1, n minus 2, n minus 3 factorial. If you want to continue, n into n minus 1, n minus 2, n minus 3. I don't actually know n, so I can just put multiply by, then dot 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 n minus n plus 1. Do you get this? Yeah, this is where it will stop. You know, the last number must be 1. So if I subtract n minus n, it will remain 0. Then this 1. So multiply by n into n minus 1 times n minus 2 times n minus 3 times whatever is in the middle. I just keep that. So the last number will be n minus n plus 1. So that aside. So the last number is going to end with something like this. So that's that for that. Now, for this question that we are told to write, you know, it doesn't stop with factorial. If there's a factorial at the back, then the whole thing is n factorial. But since there's no factorial at the back, so the answer is n factorial over n minus 3 factorial. How did I know? Because n factorial is written as n into n minus 1, n minus 2, n minus 3. If you don't want to stop it, you can continue and still write n minus 4, but let me just put factorial to tell you that I can still extend this. Now, To make the whole question remain this alone, I have to divide by n minus 3 factorial. The numerator is n factorial that I expand as this. So if this cancel this, what will I have left? N into n minus 1, n minus 2. So that's the factorial form. Now let's move to now find the number of all 5-digit numbers which can be formed from the digit 1, 2, 3, 5. 1, 2, 3, 4, 5. Assuming that a digit cannot be repeated in any number and repetitions are allowed. Let me first do with the second part, that repetition is allowed. Now, we want to form how many digit number? 5. So we are forming 5-digit number. And what are the choices? What you are forming them from what number? You want to form 5-digit number from the digit 1, 2, 3, 4, 5. So let's say to fill up this space, how many choices do we have? We have 1, 2, 3, 4, 5. So we have 5 choices to fill up the first digit. For the first digit, we have 5 choices. Are we together? Now to fill up the second digit, you have how many choices to pick? Since I'm dealing with part B, repetition is allowed. So whatever you have picked here, you don't know what, but whatever it is, you can still pick it again. So how many choices do you have to fill the second digit? You can still pick anyone because repetition is allowed. So here you still have 5 choices. To fill the third digit, you can pick any one that you've picked before. So you still have 5 choices to pick. To pick the fourth one, you still have 5 choices. And to pick the last one, you still have 5 choices. Are we together? So all your choices, 5, 5, 5, 5, 5. So how many number of all, the number of all 5-digit number that you can form from this, if repetition is allowed, is 5 times 5 times 5 times 5 times 5. That's 5 raised to power 5. So that's 5 raised to power 5, which is what? 5 raised to power 5. That's 3125 ways. 3125 ways. But if repetition is not allowed, now how many 5-digit number can we form if repetition is not allowed? Now, to how many choices do you have for the first digit? You have 5 choices. 1, 2, 3, 4, 5. So for the first digit, you have 5 choices. Are we together? For the second digit, because whatever number you have picked here, you cannot pick it again to fill the second digit because repetition, a digit cannot be repeated. So that means you only have 4 choices left. Any number you have picked is just one of these. You have 5 choices to pick from. So that's why here this one still remains 5 choices. But any number you can't pick 2 numbers to fill up just a single digit. You can only pick one. So anyone you have picked, then you can't repeat it again. So you know that you only have 4 choices left. To fill up this one, you only have 4 choices left because you cannot repeat a digit again. To fill up the third one, you have 3 choices left. To fill up the fourth one, you have what? 2 choices left. And to fill up the last one, you have just 1 choice left. So how many ways can you do that now? 5 times 4 times 3 times 2 times 1, which is something as what? 5 factorial. And I think that should be what? 120 ways, if I'm not mistaken. So 120 ways for repetition not allowed. Then 3125 ways for repetition allowed. 5 times 4, that's 20. Times 360, yeah, that's 120. Are we together? Now because here, this is it. Let me now come back to the formula. But just understand this pattern. Now, to fill the first digit, that means you want to choose one out of 5. Are we together? To fill the first digit number, you want to choose one out of 5. And that will be what? 5 combination 1. To fill the second digit, you want to pick one. Choose one or pick one or select one out of 5. Then you still have another one, 5 combination 1 times the third digit. No, you want to pick a number out of 5 to get the third digit. 5 combination 1. The fourth, same thing, 5 combination 1. The fifth, same thing, 5 combination 1. because to fill each digit, you want to form 5-digit number. That means you want to pick just one out of 5 to fill each. So the last one you still have, you want to choose one out of 5 combinations. So 5 combination 1 times 5 in 5 places. 5 combination 1 is 5. So it's still the same thing. So if you feel like writing out this pattern and doing 5 factorial over 5 minus 1 like if you want to do it this way, just a whole lot of stress. You do this one, then you multiply by this. So this is still 5. 5 times 5 times 5 times 5 times 5 times 5. 5 combination 1 is 5. That's going to be 5 factorial over 5 minus 1 factorial 1 factorial. 5 minus 1 factorial is 4 factorial. 5 factorial is 5 times 4 factorial. It comes to, just do it till you get 5. So that's that for that. Now, this one is just 5 factorial. Are we together? And it's same thing as, let me also do it in form of formula. To fill up the first digit, what do I have? I want to pick 1. To fill this place, I want to pick one number out of 5. I can choose any, but I just want to choose one out of 5. So this one give me 5 combination 1. Because I cannot repeat a number again. That one that I've picked, whatever number it is, then I can't pick it again. So how many will I have in total to choose from? I will now have 4 in total because I can't repeat a number. And because I want to choose one out of 4 combination 1. This one I will have 3 choices left because I want to pick one out of 3. 3 combination 1, then 2 combination 1, 1 combination 1, which is still same thing as 5 times 4 times 3. 5 combination 1 is 5, 4 combination. So if you like using this, maybe you turn this to get 5, then you express this, you work it out to get 5. Fine, there's no problem. This is the, so there's no issue with that. So that's that for that. Now this one says, how many 4-letter code words can be formed from the letters? How many 4-letter code words? Yeah. How many 4-letter code words can be formed from the letter ABC? How many letter code words did you want to form? 4. 1, 2, 3, 4. How many choices do you have to form them from? 6 choices. 1, 2, 3, 4, 5, 6. Are we together? A letter cannot be repeated in a code. So that is, repetition is not allowed. To form the first letter code, you have 6 choices to pick from. Are we together? So that's 6 combination 1. To form the second letter code, since you cannot repeat a letter, whatever you have picked here, you cannot repeat it again. So you have 5 choices left. This one give 5 combination 1 for the second letter code first. Now for the third letter code, it remains 4 choices because you've picked 2 already, which you cannot repeat again. Cannot be repeated. So you have what? 4 combination 1. Why is it combination 1? Because you only want to fill up 1 digit here. You are not filling 2 digits at the same time. Like, what you want to pick, like the first digit. How can you get the number that will be in first digit? So you have to pick 1 out of 6 choices. So whichever one it is, that's not the problem. You can pick any, but you are picking 1 out of the 6 choices. So you have 6 combination 1. You are picking 1 out of the 5 choices left because it's no longer 6 choices because you can't repeat 1 again. 5 combination 1. Then there is 4 choices left because a letter cannot be repeated. So 4 combination 1. Then the last digit, you have 3 combination 1. So which is what? 6 times 5 times 4 times 3. So the first one, 6 choices, 5 choices, 4 choices, 3 choices. Are we together? So if you still feel like finding what this is, working it out, you still get 6. Working this out, you get 5. Working this out, you get 4. Working this out, you get 3. I've shown us the formula. This is it. 3 combination 2 is 3. So if it is 3 combination 1, 3 factorial over 3 minus 1 factorial, 1 factorial. So 6 times 5 times 4 times 3. That should be 360 ways. 360 ways. That is if repetitions is not allowed. If a letter cannot be repeated. What if a letter can be repeated? 1, 2, 3, 4. To fill up the first digit, You have six choices, right? And since it's a digit you want to fill up there, you can call it this combination one. To fill up the second choices, since you can repeat whatever you have picked here, you can repeat it again. So you still have six choices. Whatever you have picked here, since repetition is allowed, you can pick it again. You still have six choices. Whatever you have picked here, you can pick it again. You still have six choices. So this six combination one is 6 times 6 times 6 times 6. That's 6 raised to power 4. And what do we have? That's what is equal to 1296 ways to form a four code letter block from six choices of letter if repetitions are allowed. It's allowed. So that's that for that. Now, says how many permutations can be formed from the word shokoto? How many permutations can be formed from the word shokoto? Now, normally it should have been just 6 factorial. I should have stopped there. But why can't we stop there? You have to divide by those ones that repeat themselves. Like S is only appear once, right? There's no problem. So like, okay, let's do it this way. Just take the formula like this. If you have a group of a word containing a group of letters and you want to find how many ways you can permutate it, so it's going to be what? The whole letters. If you count the whole letter, 1, 2, 3, 4, 5, 6. Yes, 6 factorial over. Should I put it that way? Okay, let me not. Don't worry. I just want to show us that you can say, okay, S appear once, then over 1 factorial. O appear 3 times, then over 3 factorial. K appear once, over 1 factorial. You don't need anyone that appear once, you don't need to put over. But I'm just trying to just show us that. Because 1 won't still affect anything. So S appear once, 1 factorial, so we don't need it. Is O appear 3 times. So divided by 3 factorial. K appear once times 1 factorial, we don't need it. T appear once times 1 factorial, we don't need it. It won't affect the answer. So anyone that appear more than once, you have to divide it by its factorial. If K appear twice, I'll say times 2 factorial again. So this guy give us what? 6 times 5 times 4 times 3 factorial. I don't need to extend it to 1 over what? 3 factorial. This cancel. 6 times 5 times 4. That's what? 120 ways. Are you clear? So now, a committee of 7 are to sit around a circular table in such a way the secretary must sit next to the chairman. In how many ways? So the formula for circular table is n minus 1 factorial. Circular table. This is circular table. If people want to sit around a circular table, how many ways can they do that? This is the formula. If it is a ring, maybe you want to arrange a bead. You want to arrange a bead around a ring. No ring that they put in the finger or whatsoever ring. You can also have some other rings too. So in how many ways can it be arranged around the ring? So the formula for ring is n minus 1 factorial over 2. This for ring. For a straight table or adjacent share, what do I mean by adjacent share? Maybe someone sits here, another share is beside it, adjacent. Another share is beside it, adjacent. It's like forming a straight line. Or on a table, and people are to sit on it, straight table. So either this or this, they are still forming a straight line. So for that one, in how many ways can this be seated? That one is just for a linear sitting. That is a straight sitting, not circular sitting or ring arrangement. For a linear sitting, linear means straight. So the how many ways they can sit is n factorial. Please take note of the 3 pattern. But this question is based on circular. Whatever we want to do is for circular, for linear, for ring. If you have the same question, it's still the same step we are going to take. The only different thing is the formula we apply at the end of the journey. So whatever I want to do now, whatever explanation I want to explain now, it goes with this, goes with this, it goes with this. But the formula just different. So now let's solve the question. So a committee of 7 are to be seated round a circular table in such a way that the secretary must sit next to the chairman. See, the secretary and the chairman, they want to sit together. So first, before you apply the formula, you have a total number of 7. Are we together? So you have to remove secretary and chairman first. 7 minus 2. What will you have left? Why do you remove them? Because those ones, they have to sit together. So count them out of the way. So we have 5 left, right? 5 left. So the 2 that must sit together, the 2 which contain secretary and chairman, see them as just one unit. Why? See them as just single because they must sit together. So total now, your n is no longer 7, it is 6. Your n is 6. Do we get? All these things, you don't even need to do it. You have a total number of 7 and 2 must sit together. So see those 2 as 1. So that means the total now is going to be 6. Is that clear? So your n is going to be 6. If 3 are to sit together, see them as just 1 because they must sit together. They must not leave each other. So see them as 1. So the total, the n will now be 5. Is it 5? Yeah. Because if you remove 3, you have 4 left. Then if you add those 3 as in form of 1, you have 5. Are we together? So since it is 7 in total and 2 must sit together, that 2, you treat them as 1. So you now have 6 in total. So the formula now will now be what? The number of ways they can sit will now be what? N minus 1 factorial multiplied by the factorial of those who sit together. Okay, those who sit together, let's call it R factorial. Multiplied by R factorial. So if no one must sit together, then you take your R to be 1. Do you get? Then you can rewrite all these formulas times R factorial times R factorial. Though they don't add it, there's nothing like that. But so you take R as those who sit together. So if there is no one that must sit together, then that means your R will be 1. Are we together? So 1 doesn't affect anything. It doesn't affect anything. So but because 2 people are sitting together, counting them as 1 unit, we've already added it to this. So we have a total number of 6. So this one is going to give us 6 minus 1 factorial multiplied by 2 factorial. So that's what? 5 factorial times what? 2 factorial. 5 factorial, 5 times 4, that's 120 times 2 equals to 240 ways. 240 ways if the secretary must sit together with the chairman. But assuming if the question says a committee of 7 are to sit around the circular table, in how many ways can the committee be seated? You just be what? N minus 1 factorial, which should be times R factorial, which should be what? 7 minus 1. Because no one is sitting together, so your N will be 7. That's 6 factorial. Since no one is sitting together, R is 1. Just they are sitting 1 by 1. So your R is 1. So it will be what? 6 factorial times 1. Is that clear? This is not part of the formula. So I'm just showing us. I should have added it, but there's no problem. So assuming 3 people must sit together, it will be times 3 factorial. Is that clear? Take note of that. So here now we have a family of 7, including 2 sisters. This formula is not there. I'm the one that just add it to explain, because you are going to multiply by the number of those who sit together. The factorial of those who sit, the factorial. So times 2 factorial. So I just say can use something like this so that you not forget. So in case anyone is not sitting together, then you know that your R is 1. So a family of 7 includes 2 sisters. A family of 7, including 2 sisters. are to sit on 7 adjacent, since adjacent seats, since they are adjacent, it's going to form a straight. So you are using this n factorial, this formula. It's a linear sitting now. A family of 7, including 2 sisters, are to sit on 7 adjacent seats at a cinema, such that the 2 sisters do not sit together. Now, this one I say such that they must not sit together. Now, let's first find, so in how many ways can this family be seated? Can the family be seated? So now, let's first solve n factorial. N factorial means when there is no condition at all, condition that they must sit together or they must not sit together. When there is no condition, maybe we are just told that a family of seven are to sit adjacently in a cinema. In how many ways can they sit together? So there's no condition whether some people must sit together or not. It gives n factorial, which is what? 7 factorial. So 7 factorial times 4 times 3 times 2. That's 5040 ways. So those family can sit together in 540 ways if there is no condition that some of them must sit together or must not sit together. There is no particular pattern to working out 2 sisters do not sit together, but this is the way to it. Now, what if those 2 sisters must sit together? Let's first do when they have to sit together. You know, the question says they do not sit together, but there is no pattern to that. But this is the only way to it. Now, if 2 sisters must sit together, so that means you have 6 left. You know, since the 2 are out of the 7, so you treat them as 1. So your n now will be what? 6 and no longer 7. Is that clear? Since it's linear, it's not circular table. So what is what? N factorial times y times 2. Why is it times 2 factorial? Because 2 are sitting together. I know I told you this r for those who are sitting together times 2 factorial, which is what? 6 factorial times 2 factorial. What's 6 factorial? 6 factorial, that's 7, 20, 30, 120. Yeah, is equal to what? 720 times what? 2. 2 factorial is 2, which is what? 1440 ways. You know, assuming if 4 people are to sit together, you treat those 4 as 1. Then this 7 will now be reduced to what? To 4. Because if you remove 4 first, you have 3 left. So if you now treat those 4 as 1 and add it back, it will be 4. So your n will be 4. But since it's just 2, that is I'm not here. The question did not say those that sit together, but I need it to find the 2 that do not sit together. And since it's 2 that must sit together, treat them as 1. So this will be reduced to 6. Or you subtract the 2 first, 5. Then treat them as 1 and add it back. You get 6. So our n is 6. So this is 720. Now, what I did now, if there is no condition at all, if all of them must just sit one by one, no one is sitting together, and there is nothing like no one must not sit together. But this one, since the question says that the 2 sisters do not sit together at a cinema, such that 2 sisters do not sit together. Now, I need to find the number of ways that all of them can sit first without a condition, then find the number of ways that 2 sisters must sit together. So I will now subtract this from this. Then the result will give me such that 2 sisters do not sit together. If you remove such that 2 sisters must sit together from the whole thing, the result will be such that they must not sit together. Isn't it? Do you get what I'm saying? For instance, you say you have 10 people rather, and they told you that 2 did not eat bread. Are we together? If they said 2 did not eat bread, and there is no way to find those 2 that did not eat bread, except you find those that eat bread. So if you find those that eat bread, how will you get those that do not eat bread? You subtract from the total. So if 8 eat bread, 10 minus 8, you get 2 that do not eat bread. So that's it. If in how many ways can they be seated such that the 2 sisters do not sit together? So you find such that the 2 sisters must sit together. which is this. Subtract it from the whole thing, n factorial, 7 factorial. If it is circular, this will be n minus 1, but it's adjacent, it's linear setting, so n factorial. So now, such that two 6 must not sit together, going to give you 5 4 5 0 4 0 minus what, 1 4 4 0. So 5 0 4 0 minus, so that's what, 3600 ways. Is that clear? So that's that for that. Always multiply by the permutation of those sitting together. The permutation of those sitting together, those that must sit together. Like, I need to work this out. Not that they ask us, but I need it. But whenever you are doing sitting, some people must sit together, then multiply by it. So now, how many odd numbers can be formed with the digit 2, 3, 4, 5, 6? And this one is like a classical question, because they did not specify that how many 2 odd number or 3 odd number or 4 odd number or 5 odd number. They just told you how many odd number. So you are going to find one odd number, how many 1 odd number, how many 2 odd numbers, how many 3 odd numbers, how many 4 odd numbers, and how many 5 odd numbers, because you only have 5 choices. So you are stopping at 5 odd numbers. Is that clear? So let's start with 1 odd number. So how many 1 odd numbers can you form? It's only 2, because 3 and from these are our choices. 3 and 5 are the only odd number. Are we together? It's only 2. So you only pick it from this and this. Are we together? So you can call it 2 combination 1. You are forming 1 out of 2, 3 and 5. So that's 2 combination 1 is equal to what? 2. I don't need to, you can work it. And I don't even need to say 2 combination 1. I can still say, okay, I only have 2 odd number. So I can form 1, 3 is 1, then 5 is also 1. 3 is 1, like 1 digit odd number. Let me call it like that. 1 digit odd number. So how many 1 digit odd number? I can form 3 is 1 digit. I can also form 5. It's also 1 digit. Is that clear? So this is it. I want to form 1 digit. If I don't want to use this formula direct, so just draw 1 dash. So to fill up this dash, how many choices do you have? 3 and 5. 3 and 5. So I have 2 choices to fill up that single dash, because I'm forming 1 digit odd number. I have 2 choices, 3 and 5. Others are even numbers, so I only have 2 choices to fill it. So the number of ways I can have 1 digit odd number from this is just 2, or 2 combination 1. So that's for 1 digit odd number. What of 2 digit odd number? 2 digit odd. So let me say 2 dashes now. Now, for this number to be odd, it is not determined by the first digit. The first digit can be even number or whatever, or prime or odd or anything. It's the last digit that determines whether this number. So if I start with 2, if it ends with 3, it's still odd, 23. But the first doesn't determine. So which means I'm going to take priority of the last digit first, because it is what determines if it is odd or not. So the last digit is what I'm going to fill first. If it's other cases, then there's no problem. Okay, let's start with if repetitions are allowed. So whether repetitions are allowed or not, for 1 digit you still have 2, because you're only forming 1 digit. So there is 3. There is no space to say, okay, you want to repeat another number again. It's just 1 space you have. You want to form 1 digit. It's still 3 and 5 is 2. So for this one, to fill up the last digit must be odd for the 2 digit number to be odd. So to fill up the last digit, how many choices do you have? 3 and 5, 2 choices. To fill up this guy, you have 2 choices. Are we together? To fill up this, how many choices do you have? 1, 2, 3, 4, 5. Whatever you have picked here, you can repeat it again, because repetitions are allowed. So to fill up the first digit, you have 5 choices. Is that clear? So now, how many ways can we do that? 5 times 2, which is what? 10. 10 ways to get 2 digit odd number from 2, 3, 4, 5. can also use combination too. Are we together? This one will give us what? 2 combination 1, because you have two choices to fill up that single digit. You want to pick single digits from 2 choices, 2 combination 1. This one to 5 combination 1, still 5 times 2. Now 3-digit odd. 3-digit odd. 1, 2, 3. You must start with the last because of the odds that they mentioned there. So to fill up this last, how many choices do you have? Just 3 and 5, because this is not odd. This is not odd. 3 and 5. So here you have 2 choices. To fill up this place, you have 5 choices, because you can repeat whatever you've picked here. You can repeat it. Any number can be in the middle or the first. Odd or even. It's the last number that must be odd to show that everything is odd. So you have 5 choices to fill up this second one, because you can repeat. The whole choice is still yours. The whole choice is 1, 2, 3, 4, 5. So to fill up the first digit, you still have 5 choices. So how many ways can you form 3-digit odd number from 2, 3, 4, 5, 6? 5 times 5 times 2. That's what? 50. 50 ways. So what of 4-digit odd? 4-digit odd. So you have 1, 2, 3, 4. To fill up the last digit, you have 2 choices, 3 and 5, 2. To fill up this, you have 5 choices, since repetition is allowed, and the whole choices is 5. To fill up this, since you can repeat the choices you've picked before, you still have 5 choices. To fill up this, you still have 5 choices. So for 4-digit number, you have 5 times 5, 25 times 5, 125 times 2. That's what? 250. So for 5-digit, you have 250. Now for 4-digit rather. Now for 5-digit. For 5-digit odd. 1, 2, 3, 4, 5. To fill up the last digit, you have 2 choices, 3 and 5. You can only pick from 3 and 5 because they are the only odd number in the choice that you have. To fill up this, you have 5 choices. It's not 4 choices though, because it would have been 4. Why is it not 4? Because repetition is allowed. Whatever you have picked here, you can repeat it. So you still have your complete choices. To fill up this, you still have 5 choices. To fill up this, you still have 5 choices. To fill up this, you still have 5 choices. 5 times 5, 25. Times 5, 125. Times 5, 625. And times 2, that's 1250. So for 5-digit odd, you have 1250 ways. So how many ways in total now? 2 plus 10, that's 12, plus 50, plus 250, plus 1250. So you have 1562 ways to form odd numbers. I mean 1562 odd numbers that you can form. It's not about ways now. They say how many odd number can you form? So it's 1562 odd numbers, not ways. 1562 odd numbers can be formed with 2, 3, 4, 5, 6 if repetition is allowed. Now, what if repetitions are not allowed? To form one digit odd, you still have 2 choices, like 2 ways. Are we together? It will still be 3 and 5. Now, 2-digit odd, dash dash. How many choices do you have to fill the last digit? It's been between 3 and 5 because they are the only odd number there. So to fill up this, you have what? 2 choices. To fill up this, how many choices do you have? The total choices that you have is 5. But because out of that 5, you've picked one to fill up this. That one is either 3 or 5, but whatsoever it is, it's 2 choices that is there. But whatsoever it is, you can't repeat it again. That means you have 4 choices left. What you used to fill here is either 3 or 5. So either of the two. You can't say either of the two. That's why you write 2 choices. So, but either of the two can be used to fill this place. So how many choices do you have left in total? It remains 4 because you've picked one. Here, you can't repeat it again because they say repetition is not allowed. So here you have 4 choices left. So this 4 combination 1, 2 combination 1. So here now you have 8 in total. 8 in total. So for 3-digit odd, 1, 2, 3. Some of those questions they specify that 5-digit code number kini kan 4 digit, but this one they just say how many odd, they did not specify. That's why we have to do 1 digit, 2 digit, 3 digit. To fill up this, you have two choices. To fill up this, since you can't repeat whatever you've picked here, out of 5 there is 4 left. To fill up this, out of the 4 you've picked 1 before, so here there is 3 choices left. There are 3 choices left. Here you have between 3 and 5 to pick. Since you've picked one of them, then the whole choices remain 4. You pick out of the 4 to fill up this, then the whole choices remain 3. So in total now, that's 3 combination 1, 4 combination 1, 2 combination 1. So 3 times 4, 12 times 2, that's 24 for 3 digits. Now for 4 digits, 1, 2, 3, 4. To fill up this, you have two choices between 3 and 5. To fill up this, since repetition is not allowed, you have 4 choices. To fill up this, you have 3 choices. To fill up the choices will be reducing because you can't repeat a number again. The reason why this one is kind of small is because you can't just pick any. You can only pick between 3 and 5 because the last digit determines if the whole number is odd or not. So all this one does not determine. You can pick any of those. So, but since you've picked either 3 or 5 here, so everything is now up to the total again. The choices is now up to 5 again because you can't repeat a number. So to fill up this, you have two choices. So 2 times 3, that's 6 times 4, 24 times 2. Here is 48, odd number. Now 5, 1, 2, 3, 4, 5. To fill up this, you have two choices. To fill up this, you have 4. To fill up this, you have 3 choices. To fill up this, you have 2 choices. To fill up this, you have just 1 choice. So this one still give you what? 48. 1 times 2 times 3 times 4 times 2, that's 48. So how many in total? 48 plus 48 plus 24 plus 8 plus 2. So here we have 48 plus 24 plus 8 plus 2. So that's what? 130 odd numbers if repetition is not allowed. Yeah, 140 odd number if repetition is not allowed. So that's that for that. Now for this one, suppose that there are 8 balls of different colors in a bag. 4 balls are to be drawn from the bag. Find the number of ways of drawing them in. What we have done before is still same thing as this. They just change the structure. Suppose that there are 4 balls of different color. Telling you that they are different color. They are telling you that you have 8 distinct balls. You want to pick 4 from them. 4 balls are to be drawn from the bag. It's just like they are saying how many 4-digit number can you form from 8-digit number? Maybe 1, 2, 3, 4, 5, 7, 8. So how many 4 balls can you draw from 8 different balls, different color? So that this one that we did, where is it? I think, yeah, this is just the idea. Suppose that there are 8 balls of different color. 4 balls are to be, so they are saying how many 4 balls, like how many 4-digit number can you form from 8 different digit number? So that's just it. So since you are drawing 4 balls, 1, 2, 3, 4, and you want to draw them out of 8 different balls. So you have, so now allowing replacement for each ball, which says the same thing as what? Repetition is allowed. It's just that same structure. They just change. It's just that same idea. They just change the structure. Or what should I call it now? So do we get? So we are drawing 4 balls out of 8 balls. And we can repeat a ball, like we can replace a ball and still draw that same ball again. We can repeat. Repetition is allowed, allowing replacement for each choice. So you can start from the first. There is nothing like odd here. So to draw the first ball, how many choices do you have? 8, because you have 8 different balls. Are we together? Or you can call it 8 combination 1. Just the first ball. You are picking one. You are picking one ball from 8. That's 8 combination 1. And you can solve 8 combination 1, you still get 8. But this is just the fastest idea. So to draw the first ball, you have 8 choices. To draw the second ball, because you can still draw that same ball that you've drawn at first. See, you can replace. Repetition is allowed. You still have 8 choices. That's another 8 combination 1. To draw the third ball, you still have 8 choices. To draw the last ball, you still have 8 choices. So 8 combination 1 times 8 combination 1 times That's 8 times 8 times 8. That's 8 raised to power 4. That's what? That's 4096 ways of drawing 4 balls from 8 ball. Or you can say of forming 4-digit number from 8-digit number if repetition is allowed. That's just same structure. 4,906 ways of drawing 4 balls from 8 different balls if you can replace for each choice. But without replacement, you want to draw 4 balls. To draw the first ball is 8 combination 1, right? The second ball, because you cannot replace the ball. The ball is already outside. So inside the box, you have 7 ball left. So here you have, and you want to draw 1 out of 7. That's 7 combination 1, which is still 7. You can't replace that one. So there are 6 balls left there. So to draw the third ball now, this is the second ball, this is the first ball. To draw the third ball, you have 6 combination 1. Because you want to pick just 1 ball out of 6. That's 6 combination 1. To draw the last ball, so you have what? 5 combination 1. Are we together? 5 combination 1 is 5. 6 combination 1 is 6. So 8 times 7 times 6 times 5. 8 times 7 times 6 times 5. So that's what? 1680 ways. 1680 ways. So that's now the next one. Find the number of combination of 5 objects from 9 different objects. Find the number of combinations. So you are not using, if you are drawing or you are picking or you are selecting or you are choosing, it's all about combination. This 8 combination 1. So if you are arranging or they mention permutate, if they say permutate or they ask you to arrange, so you are using permutation. So this one, they don't mention choice or selection, or they just mention combination. So you are doing combination automatically. So find the number of combination of 5 objects from 9 different objects. So that's, since you want to choose 5 from 9, that's 9 combination 5, which is what? 9 factorial over what? 9 minus 5 factorial 5 factorial. Don't forget the formula. You can back the video and get the formula. So this guy give us 9 times 8 times 7 times 6 times 5 factorial. I don't want to continue. 9 minus 5, that's 4. 4 factorial 5 factorial. This cancel. 5 times 4 times 3 times 2 times 1, it cancel. 5 times 4, so it cancel out. So here we have 9 times 8 times 7 times 6 over, what's 4 factorial? 4 times 3 times 2 times 1. Are we together? 4 times 2, 8. So this cancel this 8. No, 4 here. So this 4 times 2 is 8. So it cancel out. So here we have 3 times 1 left. So we have 3 here 1, 3 here 2. You can multiply directly and just divide and get your answer. So 3 here 1, 3 here 2. So we have 9 times 7 times 2 left. 9 times 7 times 2. So the answer is what? 126. Are we together? 126 combination. 126 combination or 126 choices. 9 times 8 times 7 times 6 divided by 4 times 3 times 2. That's 126. Times 3 times 8. 4 times 3, 12 divided by 24. So that's now a goalkeeper, 6 defenders, 6 midfielder, and 3 strikers have been invited by a football coach. How many team selection can be make consisting of a goalkeeper, 2 goalkeepers, 6 defenders, 6 midfielder, and 3 strikers have been invited by a football coach? How many team selection can be made consisting of 1 goalkeeper? So you cannot pick goalkeeper from defender. No, there's nothing like that. So you can only choose 1 goalkeeper from 2 goalkeeper. So if you want to, how many selection can be made? That is, how many choices can be made consisting of 1 goalkeeper. So that's, since you have 2 goalkeeper in total, so you have 2 combination 1. You want to form 1. Are we together? Times containing 4 defenders. How many defenders? That means you are choosing 4 defenders from 6 defender. 6 combination 4 times 4 midfielder. And you have 6, so you are choosing 4 midfielder from 6 midfielder. 6 combination 4. You can read the question again. And what? 2 strikers. How many strikers do we have in total? 3. So we want to choose 2 strikers from 3. That's 3 combination 2. Is that clear? So here we have what? 2 combination 1 is what? 2 times 6 combination 4. So we have 6 times 5. Cancel 6. That's 15 times 6 combination 4, 15 times 3 combination 2. That should be, I think that should be 3, if I'm not mistaken. That should be 3. So here you have 2 times 15 times 15 times 3. So it's equal to what? 1,350 team selection. Don't just write ways. There is a question they ask, how many team selection can be made? So 1,350 team selection. Is that clear? So that's that for that. 4-4-2. You can see the meaning of this 4-4-2 system is the arrangement. You know, if you have been watching, but they don't count goalkeeper as part of the formation. So the formation is defender, midfielder, striker, like 4-4-2, 4-4-2. Defender, midfielders. So this one is not part of your work. It's just like they are just telling you that the formation is 4-4-2. So don't be confused. So here we have it. 1 goalkeeper from 2 goalkeepers, 2 combination 1. You are forming 4 defender from total of 6 defender. That's 6 combination 4. 4 midfielder from total of 6 midfielder, 6 combination 4. 2 strikers from total of 3 striker, 3 combination 2. So you get it. Now, yeah, in how many ways can a group of 12 people? In how many ways can a group of 12 people be divided into 3 groups of 3, 4, and 5? A group containing 12 people. So you want to divide it to 3 different groups that one will contain 3. So now, let's leave this 4 and 5. Now, this partition now. Now, in how many ways can a group of 12 people be divided into 3 groups of 3, 4, and 5? Now, let's start with 3. That means you want to pick a group from this 12, from this another group that contains 10 people. And that group you want to pick must contain 3 people. That is, you want to choose 3 people from 12. Are we together? So if you choose 3 people from 12, then how many ways is that? That's what? 12 combination 3 times, because you don't just stop there, you want to pick 4 again. So now, don't mistakenly say this one now picking 4 from 12. No, you've picked 3 from 12. You've chosen 3. So the total number of people that you have left is no longer 12. It's now 9, because you've removed 3 from it. So the second one, if you want to form the second group that contains 4 people now, it will now be what? 9 combination 4. Are we together? So the last group that must contain 5 people, it will now be what? 5 combination 5. Because if you pick 4 from 9, you have 5 left. So this is it. It's not 12, 12, 12. You've picked 3 from 12, you have 9 left. You've picked 4 from 9, you have 5 left. So you want to pick the last 5 people, the last group containing 5 people. So 12 combination 3. Okay. 12 combination 3. That's 220 times 9 combination 4. That's 126 times 5 combination 5. I think that should be 1. 5 combination 5. That's 1. So 220 times 126. So the answer is what? 27,720 ways. Because the question is talking about ways. In how many ways? So now, a delegation of 3 people is choosing from 5 men and 6 women so that it contains at least 2 women. This is the question, sorry. A delegation of 3 people is choosing from 5 men and 6 women a delegation of 3 is choosing from 5 men and 6 women. Now, because you want to pick 3, you want to delegate 3 from 5 men. You can say that's 5 combination 3. I'm still coming, just follow me. I want to delegate 3 people from 6 women. You can call that one to 6 combination 3. And you can what? Multiply it together. But you are given a condition. So it won't just be like that. Now, I'm just showing you how this thing is going to be, because you are delegating 3. You are choosing 3 from 5 men. So 5 combination 3 for men. From 6 women, 6 combination 3 for women. But that's not the things to do yet. So, but I'm just showing us that to give an idea of how we are going to do the combination. So now, so that it contain at least 2 women, listen, you only need 3 people. Like, so that means since you want to pick 3 people from 5 men and 6 women, and the 3 people you want to delegate must contain at least 2 women. At least 2 women. So you can have 2 women and 1 man, because the total must be 3. You only want to delegate 3 people. And it can also be at least 2 women. It must not be less than 2 women. It can also be 3 women and no man, 0 man. So that's the only thing we can do to fulfill this condition. 2 women and 1 man, that's total of 3. 3 women and no man. Are we together? It must contain at least 2. It can be more than 2 women, but it must not be less than. And for it to be more than 2 women, that means there won't be man in that aspect. So now, so what do we now do in total now? So for the first one, there must be 2 women and 1 man, since the total number of women is 6. So that one will give you what? 6 combination 2 times the total number of men is 5. And here you want to choose just 1 man. Here you are choosing just 2 men, 2 women from 6 combination 2. So 1 man from 5 combination 1. So the total 6 combination 2, that's what? 6 combination 2, that's 15. And 5 combination 1 is 5. 15 times 5. 15 times 5, that's 75. 75. So 75 ways of delegating 3 people. If those 3 people are to contain 2 women and 1 man, 75 ways. But since we also have the one that can also contain 3 women and no man, because they say at least, so you have different cases. So this one now will give us, how many number of women do we have? 6. So 6 combination 3 times 5 men, 5 combination 0. So 6 combination 3, I think that should be 15 too. 6 combination 3. Oh, that's 20 rather. Yeah, that's 20. 5 combination 0, I think that should be 5. 5 combination 0, that's 1. Oh, sorry, my bad. That's 1. So this is what? 20. For it to contain 3 women and no man, you have 20 what? 20 ways. So the total will now be 75 plus 20. That's what? 75 plus 20 equals to what? 95. A delegation of 3, what did they have? In how many ways? Ways. So that's what? 95 ways. So you do the first, second, then you add together. So let's see another one. In how many ways can a committee of 7 be chosen from 8 men and 7 women so that it contains at least 2 men and at least 3 women? See this one now. We are forming a committee of 7, right? And must contain 2 men and 3 women at least. So let's start from that. If it must contain 2 men, since you are forming 7, so when you have 2 men, that means you can have what? 5 women. The total must be 7, but you must not have less than 3 men, less than 2 men, I must not have less than 3 women. So this men can increase. It cannot be 1 because they say at least 2 men. So you can also have 3 men. Then this will be what? 4 women. Then you can have 4 men. And this will be what? 3 women. You can't have 5 men because if you have 5 men, you will be having 2 women. And it must be at least 3 women. So here is where you are stopping. Because you are forming 7. So the total must not exceed or less than 7. 2, 5, 7, 3, 4, 7, 4, 3, 7. Instead of, you can't, why shouldn't I write 5 men? Because if I write 5 men, I will have 2 women. And they said at least 3 women. At least 3 women and at least 2 men. So I can't have 6 women because if I have 6 women, I'll be having 1 man. So that's that for that. Now, how many ways can we do that? For the first one, since the total number of men is 8 and women is 7, so men and women, you have what? 8 combination 2 times what? 7 combination 5. You are picking 5 women from 7, 2 men from 8. So the second one will be what? 8 combination 3 times what? 7 combination 4. And the last one will be what? That's 4 men from 8, 8 combination 4 times 3 women from 7, 7 combination 3. So this guy give us 8 combination 2, 8 combination 2. That's 28. 28 times 7 combination 5. 7 combination 5 times 21 equals to 8 combination 3. 8 combination 3. That's 56 times 7 combination 4. 7 combination 4. That's 35. 8 combination 4. 8 combination 4. That's 70. And 7 combination 3. 7 combination 3. That's 35. Are we together? 7. I'm confirming something. So 7 combination 3 is 35. Now 21 times 28. 28 times 21. You have 588. 56 times 35. You have 1960. 70 times 35. You have 2450. Now add them together. Plus 1960 plus 558. So it's what? 4,968 ways. They ask in how many ways? So 4,968 ways. So that's the answer for that. So now, the last question. Yeah, thank God. So in how many different ways can a group of 10 people be divided into 3 groups of 5, 3, and 2? We've done something like that. Now, you want to pick 5. You want to pick a group containing 5 people from 10 people. So that means you are choosing 5 from 10. So you have 10 combination 5 times. Since you've removed 5 from the 10, you formed that group already. So what do you have left here? The other group it's not up to 10 people again. It's now reduced to 5 because you've picked 5 from it. So now, here now you now have 3. You want to form another group containing 3 people. So now 5 people left. And you are picking 3 from them now. So if you pick 3 from 5 here, you have 2 left. Now you want to form another group containing 2 people. So times the 2 left, picking 2 from the 2 left. So here you have what? 10 combination 5, which is what? 252 times 5 combination 3, which is 10 times 2 combination 2. Are we together? So which is 1. So it's equal to what? 2520 ways. Different ways. In how many different ways? Then 2520 different ways. Just try to follow what they ask. Not just ways, but different ways. Are we together? 2520 different ways. So that's all about permutation and combination. Is that clear? That's all about permutation and combination. So like and subscribe, drop your comment, drop your view in the comment section. See you in the next video.